Have you ever just stopped and really thought about sound? I mean, not just what you're hearing, but how it all works? Well, it turns out every single sound you've ever heard, from the quietest whisper to a massive explosion, is actually built on a kind of secret code. And today, we're going to crack it.
So let's start with a really simple question. Think about it. Why does a tiny bird's chirp sound so, well, high and sharp, while a huge bass drum sounds so low and deep? They're both just sounds, right? Just vibrations in the air. So what makes them so completely different? That, right there, is the mystery we're about to solve.
Okay, so our first clue is a word I bet you've heard before, pitch. You probably think of it from music class, but honestly, it's the absolute key to understanding every single sound you hear, every day.
Pitch is basically our brain's internal filing system for sound. It's how it labels everything on a scale from low to high. You hear a whistle, your brain goes, okay, that's a high pitch. You hear some thunder, and your brain says, yep, that's a low pitch. It's our built-in sound sorter. Simple as that.
But that's just how we hear it, right? What's going on behind the scenes, in the world of physics? What's the actual invisible instruction that tells a sound to be high instead of low? What is this secret code? Well, here's the cool part. The answer is surprisingly simple. The big secret isn't some super complicated formula. It's all about speed. That's it. See, every sound is made by something vibrating, and the key, the entire code, is about how fast it's vibrating. And the official scientific word for that vibration speed is frequency. It's literally just a count of how many times something wiggles back and forth in 1 second. You can think of frequency as the engine that drives the sound, and pitch is just how we feel its speed.
And this is where it all clicks into place. If you want a high-pitched sound, you need something to vibrate really, really fast. That creates a high frequency, and the sound waves end up packed super tightly together. For a low pitch, you guessed it, it's the exact opposite. Slow vibrations, low frequency, and the waves are all lazy and spread out. Now, to measure all this, scientists use a unit called Hertz, or Hz for short. It's kind of like frames per second for a video, but for sound waves. 1 Hertz is just 1 vibration per second. So if a sound is 100 Hertz, that means the thing making the sound is vibrating 100 times every single second. Let's put some real numbers on this. That super low, rumbly note on a bass guitar, it's only vibrating about 60 times a second. That's 60 Hertz. But a really high-pitched whistle, that could be vibrating at 3,000 Hertz, maybe even more. The difference is massive.
So if sound is all about frequency, just numbers, does that mean there are numbers and therefore sounds that we just can't hear? Oh yeah, absolutely. There's a whole world of sound out there that's totally silent to us.
You see, our ears have built-in limits. The lowest frequency we can usually hear is around 20 Hertz. If something is vibrating slower than that, we don't really hear it as a musical note. We might just feel it, like a deep, heavy rumble in your chest.
And on the other end of the scale, the upper limit for most young people is about 20,000 Hertz. That is 20,000 vibrations every second. And what's wild is, that number gets lower as we get older. It's the reason your parents might not hear that high-pitched whine from an old TV that's driving you crazy.
Now, these sounds outside our range have cool names. Anything below 20 Hertz is called infrasound. Elephants use this stuff. The waves are so huge and powerful they can travel for miles, letting them have long-distance chats. And anything above 20,000 Hertz, that's ultrasound. Bats and dolphins are the masters here. They send out these tiny, detailed waves that bounce back and paint a picture of the world for them.
So, what does this all mean? Well, if we understand the code, we can do way more than just listen to it. We can actually start to write it. We can control it. And that, my friends, is exactly what musicians are doing all the time.
Think about a guitar string for a second. Just sitting there, it has a certain pitch. But when a guitarist puts their finger down on a fret, they're making the vibrating part of the string shorter. A shorter string vibrates faster, which means a higher frequency, which means a higher pitch. It's pure physics. And hey, it's not just instruments. You are a walking, talking sound machine that uses these exact same rules. When you go to sing a high note, tiny muscles in your throat stretch your vocal cords, making them tighter and thinner. This makes them vibrate faster, and bam, you get a higher pitch. You're manipulating frequency without even thinking about it. Now that we've cracked this code, humanity has figured out how to use it in some truly mind-blowing ways, especially when it comes to those frequencies that are completely invisible and silent to our ears.
Seriously, this is where knowing the code becomes a superpower. We use ultrasound, those super high frequencies, to safely see inside a person's body. And we use infrasound, those super low frequencies, to listen for things like earthquakes happening on the other side of the planet. We are literally using sounds we can't hear to see the invisible and sense the distance.
So we've cracked the secret code of sound. And in doing so, we've unlocked this whole new way of seeing and understanding the world. It really makes you wonder, doesn't it? What other invisible secrets are hiding just beyond our senses, just waiting for us to find the code?